Types of agent program. In this, we have five types of agent programs. That is simple reflect agent, model-based reflect agent, goal-based reflect agent, and utility-based reflect agent. And we have learning agent. These are the five types. Here there are only four types are shown, and one more type is called learning agent is also there. So simple reflect agent, model-based reflect agent, goal-based reflect agent, utility-based agent, and learning agent are the five types of agent programs. First, we'll discuss what is simple reflect agent. So simple reflect agent is the simple, very simple, simplest kind of all the agents. Okay, and this agent, whatever action this agent takes, that depends only on the current percept. So it just ignore the percept history. So this is does not require any percept history. The whatever action it is performing, it just depends upon the current information. That's all. Okay. The example of this is vacuum agent. You know that vacuum cleaning agent. So a vacuum cleaning agent, if you see that how this is tabulated, it is tabulated like this. So what the percept sequence takes, percept percept will have the location and the status of that location. So what is the location here? We have only two locations, A and B. The status is clean or dirty. So if it is dirty, it has to clean. If it is clean, it has to move to the other location. Okay, so this gives us the agent function. This table gives us the agent function, and the agent program is given like this here. This simple reflect agent will be taking only two informations as a current percept, that is location and status, and it returns the action corresponding to these two. Okay, so if the status is dirty, then it returns suck the dirt. Okay, so if the location is dirty, what it has to do? It has to clean the dirt. Say if the location, if it is in the location A, then it has to move to right. So else if it is in location B, then it has to move left. Okay, so it will be performing only three actions, that is search, moving right, moving left. Okay, depending on the percept, that is the location and status. Now, for example, imagine yourself as the driver of automatic taxi. So, if the car in front brakes, what happens? The brake lights will come on. So, what that we should do? We should notice that brake light. Then we have to initiate the braking. Okay. So, from this, what we can say from the visual inputs, we using visual inputs, we should establish the connection called car in front brakes. Then this triggers some connection in the agent program to take the action, that is initiate braking. Okay. So that is the connection is called condition action rule. So based on some condition, it has to take the action. So this is called condition action rule. So how it will be written? For example, if car in front is braking, so this is the visual input it is having. So based on this, there is a connection will be established in the agent to initiate the action. What is the action it will initiate? That is called initiate braking. Based on this condition, it is taking some action that is called initiate braking. Okay. So the structure of this agent, which is based on condition action rules, to take the action is given like this here. You see this is the figure, and here what is that? From the sensors, we will be coming to know about that is agent will comes to know about the status of the world. That is status of world is nothing but environment. So it is coming to know about the environment. Now using this percept and condition action rule, it has to take the action based on the condition action rule. It has to take an action that is given to the actuators. The same action will be performed on the environment. Okay, so this is the simple diagram of simple reflect agent. Okay, so just now you see so that shows that how condition take the action from percept to action. Condition action is a connection from percept to action. Okay. So directly there is a based on percept, it is not taking any action. So it will just refer this condition action to select an action. Okay. So if you see this program here, we're moving from so we have to see this program student. So we have to have percent. From the first information we are getting from the sensor, that is called percept. Based on percept, it is going to know what is the status of world. So that is what we have discussed. No? From the sensor means what is the percept we are getting. So from that what we are coming to know, we know about what is the status of environment. Okay, status of environment will be getting from the percept. Okay, now this state of the environment and rules, this condition action rules are there. No, so this action rules will be given as the input. From this, it will just select what is the first rule that matches this particular state. Okay. So from this particular state, for this particular state, what is the rule is matching, that will be selected by using rule underscore match function. Okay, it will match the rule to that particular condition. So that rule is given as the input to rule action. This is the function for which rule is given as the input. So based on that rule, it will select what is the action to be performed. Okay, so it will return an action. So this is the program. So what is this? It will do. It acts according to rules. It is based on the rules only. It is acting. Yes or no? So this is the simple reflect agent. So if you observe this simple reflect agent will work only in the fully observable environment. If the environment is not fully observable, so if there is a little unobservability also, so it will cause serious trouble. For example, if you take vacuum cleaning agent is a simple reflect agent, I told you. So in that agent, if the sensor is not working, the location sensor is not working. So it has only dirt sensor. Okay. So what happens if there is any dirt? It just clean the dirt. The dirt sensor work is over. So since the location sensor is not working, what happens? It will be stuck there. It will not do any operation because location sensor is not working. So to avoid this situation, what we can do? We can randomly make the reflect agent to select either to move left or right. Okay. So if the reflect agent is randomly select either to move left or right. Based on that, what it will do? Maybe in 2 steps. After moving left, then it has to move right. Okay. So after, maybe in 1 or 2 steps, it will be reaching the next location. So if the next location is dirty, what it will do? It will clean. Okay. So it means that if this randomness is implemented in the reflect agent, then what is that agent is called? Randomized reflect agent. Okay. So this randomized reflect agent will be performing better than deterministic reflect agent. In deterministic reflect agent, all the sensors are working. If any sensor is not working, in that case, deterministic reflect agent will not perform well. Okay. So to make the deterministic reflect agent to be performed well, so what is that? It has to do select the actions randomly. So if it is selecting the actions randomly, then what is this called? It is called randomized simple reflect agent.